Here goes part 2 of day 12 of Advent of Code. In the previous part, we parsed through some instructions for a ship to help it navigate through a storm. And now we realize we need to make some updates to our code that parse those instructions, because it turns out there is a waypoint that guides our ship in its movement. So each time we receive these north, south, east, west instructions, they will actually update the position of the waypoint. And it's only when we do an F forward action that we move the ship in the direction of the waypoint. As for the L and R actions, those tell us to move the waypoint either left or right, clockwise or counterclockwise, around our ship. So the example down here describes we have the waypoint starting as 10 units east and 1 unit north of our ship. So if we get an F10, then we are to move our ship 10 times towards the waypoint, so that'd be 100 units east, and then as well as 10 units north, because 10 times 10 units east is 100, and 10 times 1 units north is 10. If we get this N3, then we adjust our waypoint so that it's now 3 more further north, so it's now 10 units east and 4 units north. F7 then has us moving 7 times, so 70 east and then 28 north. And so we'll continue to maintain sort of the position relative to our 0, 0, because we're still trying to produce a Manhattan distance at the end. Then another tricky piece is the R's and L's. So this R90 will rotate the waypoint around our ship. So it'll move this 10 units east will now be 10 units south, and the 4 units north that we started with will now be 4 units east. Yeah, so that's the problem. It definitely complicates the first part a bit, but I think we can figure it out. So yeah, let's give it a try. So here's our part 1, and I'm going to save this as part 2 because I want to reuse a lot of it. Okay, and let's see. So we have a class for maintaining some data about the ship. It seems like we're going to have to also maintain waypoint data, and I'm wondering if that should be its own class or if that's just something we want to, I guess, initialize as part of the ship's data. I think we might just update that here. So let's say, well, the waypoint is going to have sort of an X and a Y. If they're positive or negative, I guess that tells us the whether it's north or south or east or west. I wonder if it makes sense though to maintain like a north to south bearing plus a value, and then east to west bearing plus its value. If that would be any more useful than just maintaining, a north-south value that's either positive or negative, and an east-west value that's positive or negative. I mean, I do like the idea of maintaining 2 values rather than 4. The only other sort of factor that I'm considering is whether that will complicate the right and left thing that we have to do, rotating the waypoint around the ship. Well, maybe we'll figure that out when we get to it. I'll go ahead and say that we're going to... Oh, why are we in paste mode? Okay. I'm going to say that we yeah, we have our X and Y for the ship and the ship's heading. And then, yeah, we'll get a waypoint, which, yeah. Let's create a struct. So we'll say a waypoint gets struct.new, and we'll say north, south, or let's call it XY. So the X is the east to west. So waypoint.new, so it will start with, per the instructions, 10 east and 1 north. Okay. So now these north, south, east, west are not going to advance the heading, but they're going to advance or adjust the waypoint. Yeah, we'll have adjust waypoint, and then I think we'll probably end up with rotate waypoint. So for adjust waypoint, yeah, we'll do something similar to what this function down here does. Yeah, so we'll take these. It'll take in a heading and a value. So I'll add that. So 2 arguments are heading and value. So if we are heading north, then waypoint.y gets added to that value. Otherwise it gets subtracted. Otherwise we're dealing with X. Gets added that value for headed east. Otherwise it gets subtracted from the X value. Okay, so adjust waypoint. Let's update each of those. So I feel good about that. We've handled a bunch of our instructions right there. The F, I think, is forward, so that can still call it advance with heading, but we're going to have to take more into account there. Yeah, I guess that it's not the heading that matters. It's the waypoint that gets taken into account there. So if we get rid of heading, then rather than doing all of this, we will say that the Y position gets set as, I guess gets a value added to it, which will be the, what do we call it, the waypoint dot y times the value. Yeah. So if we have, whether we have a negative or positive, it'll move the y position in the right direction. And then we should do a similar thing with x. Oops, a little too permissive with my sutra in place there. Waypoint, not wax point. Great, so that updates both of those, and I guess that's the trick to advancing the heading of the ship. So there's nothing else to do there. And yeah, these are going to be the trickiest pieces, the R and the L. So right now we're calling compute new heading. What can we reuse here, and what do we need to do differently? Yeah, I guess my original thinking was to do something called rotate waypoint. So if we start out with, right, like a waypoint of 10 and 1, and then, or I guess in the example it's 10 and 4, and then we rotate it, we go right by 90, then what we need to produce is a waypoint of 4, negative 10, because it's now pointing, right, it was pointing east 10, and now it's pointing south 10, and it was headed north 4, and it's now headed east 4. Huh. So, yeah, how do we... Maybe we'll just do a little more pattern matching here. So that was a good example. What if we say like R180, then the waypoint should go from, I guess it should just negate things. It should now be negative 10. Four? Yeah, because it would still be negative 10, negative 4, because it was north, now it's south. Yeah, I think that's right. So then, let me just think through that again. So this is 10 east. If I rotate it 180, it's now west 10. And yeah, it should be the same thing. It should go from north to south then. That would be a 180 move. Okay. So then what about 270? Right, we start 10. Yeah, I mean, it seems like we're either like, it's some combination of like swapping the values and like negating them. So $360, which is also the same as R0, would just leave us with the same values. So then what's in between negating them and having the same ones versus up here where we flipped them like this? Do we, maybe it's like this gets negated and this stays positive, but they flip. So that makes sense. We would go, that would be west 4 and then 10 to the north. I think that makes sense because really it's just like a 90-degree movement from here. So we flip them and negate the one on the right. So I guess, yeah, each 90 that we move, move to the right is flip X and Y values and make Y negative. And that's sort of the formula to make each of these work. So we flip the X and the Y, and then we make Y negative. So there's probably a little more of a formula to it, but I sort of like the simplicity of thinking about it like this. So if I'm given some, what is rotate waypoint going to receive? Yeah, a turn direction and a value. So then we take the turn direction and we turn it into headings of degrees. Kind of curious how we're going to treat the L, but we'll just start here. And we'll say, give us the current degrees. No, it's a little bit different. New degrees though, that. New degrees. I think we just want to know the degree change, not some new set of degrees. So this isn't quite right. I don't think headings to degrees is gonna help us either. Or no, it is, because no, okay, so turn direction is gonna be R or L. So if it's R, then we have the value. So I think we just want to figure out how many 90-degree adjustments we're making. So yeah, we'll just take the value and we'll divide it by 90. And that will be number of 90s because then for each 90 we can flip the x and the y values and make it negative. So let's see. Just trying to think through how to handle the L value. If we get negative like 90, for instance, if we get L90, we can think of that as negative 90, which is really just 270. Okay. So if so value maybe gets set to 360 minus value if it's a turn to the left. Will that work? I think so. Just in case we have a large negative number, I'd like to do value mod 360 minus 360 or subtract that from 360. So I guess if we get 0, then we end up with a value of 360. So that's I guess we could mod the whole thing by 360 again then. I feel like I've really overcomplicated this, but that's how we're going to produce our value if the turn direction is L. So the number of turns is the value divided by 90. So then for each 90-degree move to the right. We flip the x and y values and make y negative. So yeah, so I guess we do number of 90s times do, and we are just updating the waypoint. So we'll say waypoint x gets temp x, and then we'll say waypoint y gets, and we make y negative. So we'll say waypoint y gets, x gets waypoint y, and then waypoint y gets temp x, it's negative temp x. So we'll just do that many times, and then we have our updated waypoint. And we don't need this. Okay, rotate waypoint. That's going to replace these. Okay, I think we do have a solution. I don't know if it's the right solution, but it's at least a starting point. So let's try it with our sample input first. And that was the wrong file to run. Really part 2, 286. Oh, wonderful. I have a pretty good feeling about that. If we got that right, I think there's a good chance that this main input will work. So let's save that and give it another run. We produced another number pretty quickly. It's kind of a big number, but I could see that being the answer. Here we go. All right, we got a second gold star for the day. That was a rather tricky problem. Thanks for bearing with me on the solution, and yeah, I'll look towards getting some more gold stars tomorrow. Thanks for watching.